So we're looking at space, lesson 2. Now before we begin, I just wanted to point out that there is no space lesson 1 video because that was an investigation using pendulum motion. So we jump straight into lesson 2 with space. And what we're obviously going to be looking at is weight, hence the weightlifter with her fantastic technique. And so our first question is to define weight. And we're going to define it as the force on a mass due to the gravitational field of a large celestial body. Now, what we want to do is break this down so we know exactly what we're talking about. The first thing I want to break down is that field component of what is a field. Now, obviously, we're not talking about the type of field in our image, although it is a lovely image. What we want to define it as is a region in which each point therein is affected by a force. Or another way we could say it is an object in that region will be affected by a force. Now, this is obviously a very generic definition, and this would be applied. You could apply this to an electrical field or a magnetic field, or all types of force fields we could apply this to, and it would still make sense. Obviously, we need to talk about gravitational fields. So, the way we define a gravitational field is a region surrounding a mass in which each point therein exerts a force of attraction on other objects with mass. So, this does have an implication. This implies that any objects, such as these two gentlemen, have a gravitational attraction to each other. This gravitational force is, of course, exceptionally weak. So we can't feel that attraction between each other, nor can I feel an attraction between the laptop I'm filming this on or any other object. So this force is exceptionally weak, and it only produces a sizable force, or a force that we could recognise, when one or both of the objects are massive. And when I say massive, I mean by celestial standards. Now, the expression we use to determine weight is W equals mg. And on Earth, that g is obviously 9.8. Now, at this point, it's important to make a quick distinction. Obviously, we all understand the difference between mass and weight, and they do not equal each other. But when you get questions that refer to weight, in inverted commas, they're often referring to mass. And like I said, comes up in a couple of questions. It'll come up in a question you have to do in lesson 3. Now we need to look at the value of g on the surface of other planets, because it's obviously not going to be 9.8. So it does depend upon the mass of the planet and its radius. And the equation that we use to relate these variables is g, or gravity, equals the gravitational constant, which we can find on your HSC datasheet, times the mass of the planet over the radius squared of that planet. Now this, you're not required to know this, however you are required to use it. Therefore, if you are ever required to use it, it'll be given to you. And you will be required to use it in this lesson, so please make a note of it so it can be used later. Now, with celestial objects in our universe, specifically our solar system, being that they're substantially different sizes, they will of course have a different force of gravity. And as such, a single individual's weight will vary from planet to planet. Now, your task today, which is a syllabus dot point, you are required to research the different masses and the different radii of different objects in the solar system, and then determine their different gravities. So, from those gravities, you'll then need to calculate the weight of a 100 kilogram person on each surface. So that's your task today. You've got a nice, neat table there to fill out and complete. Then some questions to follow on from that. I'd also like to point out that there's a fair bit of homework following that work. I'm going to provide you with a link down the bottom in the description of this video, a link which can help you with that homework, particularly on the reliability, validity and accuracy component. It's a very useful website. In fact, that's where I modeled the questions from, so they should be able to definitely help. I'd also like to point out that there is no lesson 3 video, because you can just jump straight into those calculations. It doesn't need any input from me. You should be able to just use the weight formula, and maybe one or two questions might require very simple vector addition or simple motion formulas from the prelim course. So get started with, firstly, you need to work through your calculations for the 100 kilogram person on a different surface, and then the questions that follow it, followed by the homework.